Hi everyone, dear students. Glad to meet you again through this video. And this is chapter 8, exercise 8.4. And uh, I heard that many of the students are finding difficult in proving this fifth question, which has 10 subdivisions. All are like proving the left hand side is equal to the right hand side. So I thought to put a video on this. So before getting into the sums individually, I'm going to work out all the 10 sums here. And before that, you need to know few things, the basic things of the trigonometric ratios and identities. So I would like to discuss about that in this video. So the first thing is like you need to know the ratios uh, with the ratios, trigonometric ratios. The trigonometric ratios. So as you all know, the six ratios I want to classify into some three categories. The first one is like simplest. The next is like simple, and the last is like complex or complicated. We can take like that. Okay. So the first one. So you know all know the trigonometric ratio: sine, cos, tan, cosecant, secant, and cot, isn't it? So that I am going to write in under three categories. So it is like the first one you can write the sine, and cos you can write under the simplest form. So for, those are the simplest, like sine theta, cos theta. The next is like tan theta, that will come under the simple form, and the complex form are like cosecant theta, secant theta, then cot theta. So what you have to do is like in proving those uh, sums like LH is equal to RHS, whatever the terms are in simple form, if the terms are in simple form, you have to try to bring it to the simplest form from here to here. Okay, like that. If the terms are in complex form, that also you have to try to bring it to the simple form, sorry, simplest form. Okay, so if you do so, you can easily prove those kind of sums and without any confusion. Okay, so you need to know, you need to understand these three categories. The next thing I want to first this is reciprocals. So reciprocals, the sense, so reciprocals of the trigonometric ratios. Hope you know that, but still I want to discuss it here once. So sine theta, this we can write as reciprocal of 1 by cosecant theta. So in reverse, we can write cosecant theta as reciprocal of sine theta. Okay, what is the next? Cos theta. Cos theta we can write as 1 by secant theta. That in reverse, we can write secant theta as 1 by cos theta. Okay, the last one is tan theta. This we can write as 1 by cot theta, and reverse cot theta can be written as 1 by tan theta. Okay. So the one more conversion that uh, is the tan theta can be written in terms of sine and cos, that is sine theta by cos theta, and here cot theta be written as cos theta by sine theta. Okay, so these reciprocals you need to know clearly, so that wherever you need, you can write in the required form so as to bring the RHS or LHS, whatever we need to. Okay, so this reciprocals you need to know. And the next thing I want to discuss about is the three identities. The important three identities in trigonometry are it is okay. So the first identity is first one is sine square theta plus cos square theta equal to 1. Okay. So this, you know, that this is the first identity, and in what are all the way this can be transformed, this can be written, that you need to know. So the first thing is like uh, if I want to keep cos square theta on the left hand side, how I can write, become cos square theta equal to 1 minus this sine square theta will be moving to the right side, transposing it to the right side, become 1 minus sine square theta. Okay. And suppose if I want cos theta, means I can take square root on both side. So what it will become? It will become cos square theta equal to 1 minus sine square theta, taking square root on both sides. So here this square root and this square will get cancelled, and as a result you will get cos theta equal to 1 minus the whole root. So this is one thing that we can get from here. Okay, and what else we can, the same can be transformed in a different way, like this also. So in the next process, what I'm going to do is I'm going to retain the sine square theta on the left side and take the cos square theta to the right side. So sine square theta equal to 1 minus cos square theta. Again, if I have to get sine theta alone, means I have to get take square root on both sides. So this will become cos square theta, and taking square root both sides. Okay. And here this square root and this square will be cancelled, and as a result you will get sine theta equal to 1 minus cos square theta the whole root. Okay, so we have to understand that the sine square theta plus cos square theta equal to 1, that identity can be written in other ways also. Using that identity we can get the cos theta as square root of 1 minus sine square theta, sine theta equal to square root of 1 minus cos square theta. So these you need to know. And the next identity is taking the second identity. Identity 2. What is identity 2? 1 plus cot square theta equal to cosecant square theta. Okay. In what way we can write these identities that you have to discuss? So suppose the first case, if I want to keep 1 on the left side, I can take the cot square theta to the right side. So it will become cosecant square theta minus cot square theta. Okay. So this is one way we can get equal to 1. And suppose this is one way, and the another is like take the another way is like keeping cot square theta on one side. Okay, so before to that, cosecant square theta. Suppose if I want to cosec theta, change this like cosecant square theta equal to 1 plus. Just I am flipping the equation. I'm not doing anything new. Just to flipping the equation, writing the RHS on to the LHS and moving the LHS part to the RHS. Just to flipping the horizontal flipping I'm doing. And from here, if I need cosecant theta, means I can take square root on both sides. You can understand. After that, take square root both side. This you can cancel, and thereby you will get the result like cosecant theta equal to okay. So this is the one way of writing. Okay, suppose another way is like suppose if I want cot theta, so I can retain cot square theta the left side and take the 1 to the right side. So if you transpose 1 to the right side, it will become minus 1, isn't it? So cosecant square theta minus 1. From here, if we need cot theta, then again the same process of taking square root both side, thereby cancelling this. So from this, get the answer as cot theta equal to cosecant square theta is 1. So okay, fine. So this way also we can write. So one more identity. Third identity is third one is 1 plus tan square theta equal to secant square. So in what way we can rearrange? So as I have told discussed for the previous one, the same way here also, if we transpose this tan square theta to the right side, keeping 1 on the left side, and if we transpose secant square theta, and if we transpose this tan square to the right side, it will become 1 equal to secant square theta minus tan square theta. So this is one way of writing, and the another way is like if we just flipping and writing the flip method, what like that, if we flip and write secant square theta equal to 1 plus tan square theta, and from here if I want secant theta, means taking square root both sides, thereby this will get cancelled, and as a result we'll get secant theta is equal to 1 plus the whole root. Okay, so this is one way of getting, and the one more way of transposing this, that is, suppose if you want a tan theta, then you can transpose. First you keep the tan square theta on the left side, the right side you already have secant square theta. Transpose this 1 to the right side, it will become minus 1. And now if we need tan theta, means taking square root on both sides, and here this get cancelled, and as a result we'll have tan theta equal to secant square theta minus 1, the whole root. Okay, so these are the different way that we can transpose and write the third identity. Okay, so these transposing you need to know, so that it will help you in proving those kind of sum. Okay, and the last one I want to discuss with you is about the powers. Writing trigonometric powers. Trigonometric powers. Hope you know this, but still I want to insist on this. Suppose if we write like sine theta the whole square means this is equivalent to what? Sine square theta, right? Both means the same. So because everywhere we cannot put this bracket and write, it will be a lengthy procedure of writing, so you can write like this. So this is applicable for any exponent. So it can, any exponent as well, it is for any trigonometric term. So if we have cos theta whole cube, means is nothing but cos cube theta, right? Both means the same. So this you need to know. And that's all. So once you know these basic things about the trigonometric system, identities, it will be easy for you to prove those sums based what I have, as I told you in that exercise 8.4 fifth question and all the 10 subdivisions. So I think with this video I want to wind up this, and in the next video I will be uploading all the 10 subdivisions one by one. Okay, bye bye, see you.